This research introduces ClickDiff, a controllable conditional generation model for grasp generation that leverages a fine-grained semantic contact map (SCM) to address the limitations of traditional approaches. SCM is a novel contact representation method that obtains representations of points on the object that are touched and the fingers touching those points, enabling customization through clicking to achieve user-controlled interactive generation. The proposed dual generation framework consists of two modules: the Semantic Conditional Module, which generates contact maps using SCM as conditions, and the Contact Conditional Module, which synthesizes hand grasps based on generated contact maps and object point cloud information as conditions. The tactile guided constraint is introduced to extract pairs in the SCM that represent touching and integrate contact information into the Contact Conditional Module. ClickDiff utilizes a conditional diffusion model framework to improve the fidelity of generation through user-specified contacts. The method addresses the challenge of controllable grasp generation by focusing on fine-grained contact information between fingers and objects. SCM is a 2D matrix that indicates the points on the object that are being touched and the finger parts touching these points. The training process involves using a conditional generation model to infer probable contact maps based on user-specified or algorithmically predicted SCM. The Contact Conditional Module then uses a conditional generation model based on contact maps predicted by the Semantic Conditional Module and constrained by SCM to infer monoparameters. The testing process involves combining the contact map predicted by the Semantic Conditional Module with features extracted by PointNet as input to the Contact Conditional Module, and estimating monoparameters. The proposed method achieves more natural and precise generation results compared to conventional methods that rely solely on contact maps. The use of SCM and TGC allows for more precise prediction and control of grasping through user-specified contacts. The ClickDiff model employs the Contact Conditional Module and Semantic Conditional Module, which utilize a tactile guided constraint loss function to ensure accurate alignment of fingers with designated ground truth contact areas. The training losses for these modules include reconstruction loss, contact map-based loss, and tactile guided constraint loss. The model is trained on the GRAB and Arctic datasets, with object features extracted using PointNet and optimized using the Atom Optimizer. Evaluation metrics include mean per joint position error, mean relative root position error, contact deviation, and success rate. The proposed method, ClickDiff, introduces a novel approach to controllable grasp generation using diffusion models. The key innovation is the Semantic Contact Map, which enables users to define contact conditions by simply clicking on the object. This map is used in conjunction with a dual generation framework and a tactile guided constraint to generate grasps that satisfy the desired contact conditions. Experimental results demonstrate the effectiveness of ClickDiff, outperforming state-of-the-art methods in terms of MPJPE, CDEV, and success rate. Ablation studies show that the use of semantic contact maps leads to a significant reduction in contact deviation and improvement in success rate, while the dual generation framework results in an increase in success rate and decrease in CDEV. The tactile guided constraint is also effective in ensuring finger alignment with designated ground truth contact regions. The proposed method is computationally efficient, with a moderate increase in controllable grasp generation time compared to models without contact conditions. Overall, ClickDiff demonstrates superior performance to existing grasp generation methods, both qualitatively and quantitatively, and has the potential to enable more accurate and controllable robotic grasping in real-world applications. Here is a combined summary of the 4 pages. ClickDiff, a novel method for generating and controlling grasp contact maps, leverages diffusion models to predict the interaction between hands and objects in 3D space. This approach utilizes a deep neural network to estimate the semantic contact map, which encodes spatial relationships and contact points between the hand and object. The model is trained on a dataset of hand-object interactions and evaluated through various experiments, demonstrating its effectiveness in predicting and controlling grasp contacts. The ClickDiff model builds upon previous research in hand-object pose estimation, motion synthesis, and grasp generation, and highlights the importance of datasets such as ContactDB, HO3D, and Arctic for training and evaluating models. The Semantic Contact Map, a crucial component of ClickDiff, represents the interaction between hands and objects in 3D space, enabling the understanding and prediction of human-object interaction. The authors acknowledge the limitations of current methods and emphasize the need for further research in this area, particularly in addressing these limitations and exploring new applications for hand-object interaction models. The proposed model has significant implications for robotics, computer vision, and human-computer interaction applications, enabling the generation and control of grasps in a more accurate and efficient manner. Through the use of diffusion models, ClickDiff can generate and control grasps, making it a valuable tool for various applications. The author's comprehensive research and acknowledgement of previous work in the field demonstrate the significance of ClickDiff as a novel approach to hand-object interaction and grasp generation.